Hello, it's Mr. Doro. Today we're going to learn about percent composition, which is formula stoichiometry. When you're given a formula for a compound, you're going to be able to find out the percent composition by mass for the elements in that compound. Here is the formula that you're going to want to write down for percent composition. It is also called mass percent because it is based on the percent composition by mass in a compound, and it is the total mass of an element in a compound. You pick out whichever element or whichever element you're asked to find, divided by the molecular mass or the molar mass of the compound, which is found on the periodic table, times 100, and that's going to give you a percentage. So here are two compounds that should be familiar to you. This one is water, and this is hydrogen peroxide. Compounds have a fixed composition. That means water is always going to be 2 H's for every 1 O. Hydrogen peroxide is always going to be 2 H's for every 2 O's here. And so these will never get mixed up, even though they have H's and O's. They have different properties because of their composition. So if we wanted to find the percent oxygen in each one of these, then what we would do is we would have to have the total mass of the element in the compound. This one right up here, since there's only one O, one oxygen in each one of these formulas, then we're going to write the mass from the periodic table of that oxygen, which is 16.00, and divide that by the total mass of this compound. And in this compound, it is 18.02. Then times 100, and that is going to give us 88.79% oxygen. Now we can find the percent hydrogen. As long as we did this one correctly, we could go through all of this for hydrogen, put 2.02 because there's 2 hydrogens over 18.02, or we could just do 100% minus this since hydrogen is the only one left over. And just for sake of time right now, that's what I'm going to do. That ends up being 11.21% hydrogen. Okay, so for this next one down here, and I could put a box around those. For this next one down here, hydrogen peroxide, the percent oxygen, in this one now, we have 2 oxygens. And so the total mass of the oxygen in the compound is not 16.00. The total mass is 16.00 times 2, which would give us 32.00 over. And now our total mass for this compound is 32 plus the 2.02, gives us 34.02. And then we, times 100, and that gives us 94.06% oxygen. And I'm going to do this hydrogen on this one. My total mass of hydrogen in each one of these formulas is 2.02 because there's 2 times 1.01 over 34.02 times 100, and that gives us 5.94%. That wasn't very tough to do, so it's always good, just in case you got the first one wrong, to go ahead and do that second one. So these are the percent compositions by mass for H2O and H2O2 of oxygen and hydrogen. So here is a typical problem that you might see for percent composition. It says, what is the percent composition by mass of each of the elements in sodium sulfate? First thing that we got to do is write the formula for sodium sulfate. Sodium is Na, and sulfate is SO4. Then we check the charges on them. Sodium has a +1 charge, sulfate has a -2 charge, so we have to crisscross and we end up with Na2SO4. Now we're going to need the molecular or molar mass of this whole compound, so we're going to go ahead and calculate that. Why don't you go ahead and calculate that right now? Look at your periodic table. Sodium times 2 plus sulfur plus oxygen times 4. And I got that molecular mass to be 142.05. And if it's molecular, it's going to be AMUs. If it's molar mass, it's going to be grams. So now we're going to do each one here. We want the percent sodium. We want the percent sulfur. And we want the percent oxygen. And so for sodium, it is going to be, each one of these are going to be over 142.05 times 100. This one, 142.05 times 100. And this one, 142.05 times 100. Okay, so the sodium, there are two sodiums in there. Each sodium is 22.99, so that is going to be 45.98. That is the mass from the periodic table. Sulfur, there's only one of them, so that's 32.07. Oxygen, there are four of them, times 16, which is going to be 64.00. Then we're going to calculate these percentages, and if we do it right, they should add up very close to 100%. So the answers I got were 32.37% Na, 22.58% sulfur, and 45.05% oxygen. And I added all those up, and they did equal 100%. Sometimes when you add them up, they may equal just under 100%, or maybe just over 100%. That's because of the way we rounded the molar masses from the periodic table. Okay, here's one for you to try now. What are the percent compositions by mass of each of the components in C6H12O6? So I need percent C, percent H, and percent O. So pause it right now and do that. And finally, here's the last one. What's the percent composition by mass of each element in NH3? Percent N and percent H. I think you'll find that these are pretty easy once you get the idea down. So have a good day.